Okay, so dear everyone, welcome back to session 3 of the GIDA Skillup Summer Bootcamp, week 6, session 3. Yeah, sharing my screen now. I'll screen this. Okay, so first of all, past 3 sessions, we've talked a lot about testing, right? From introduction to testing to a little bit advanced integration testing that we covered in the last class. We did the introduction to .NET Foundry to SM Forge, and we did a lot of integration testing in the previous session. We learned how to ignore tests, filter tests, and custom filling SM Forge. So if you have any questions on the previous lessons, right, you can just either leave in the chat, wait till the end of the session. I'll try to make this session as brief as possible so we'll have more time to answer questions. Yeah, overall it has to be brief. But in this session, we would like to touch a few things also. Okay, so in this session, we'll do testing events, we'll safe dispatcher, and we'll learn about false testing. Then we'll go into answering questions and define our for this week, right? So yeah, let's just go into our code. So the code that we wrote the previous class, that contract that we use. I believe I shared this. I shared this in that day. I think I did that. I think I shared it in the chat. We shall have to this code. And yeah, the video will be up on YouTube very soon. So this track and how it works, right? And over to our tests. Let's test on how to deploy the contract or tested the initial counter. There might be some jigs in the code from the last class, slight minus, and that's because I wasn't able to record it before my laptop crashed. So I had to like rewrite it. Okay, but it should work either way. Let me just try it from here. I don't remember if I understand. But then Windows is most likely going to be slower. Yes. Apart from this talking, let's just go straight to what we have to do today. So, first of all, I'd like to answer like one question from one person before we continue. Anybody? Just one question, then we'll move on. Then we'll answer the remaining questions later. Is there anybody that has any question concerning what we've done in the past? Okay, you can write the question.
Okay, GM sir. My question is from I saw something in your slide and I was just curious. The wrote advanced
So,
test. Yes,
can you hear?
can you hear me?
Yeah, I can hear you now.
Okay. You in your slide they said avant testing. So I want to know what is that testing loop that you wrote there in your slide.
which is testing loops, right, was part of what we did, right? If you remember, we talked about available gas feature, right? I'm just a little bit explain. So we talked about testing and we talked about the available gas. I don't think I have that code here, but I always do that. So basically, testing loop is in recursive code or code that is quite expensive to run, right? On the blockchain, there's something we call gas, right? It's a measure of the computation that is required to run the code. I think that's a good explanation. So when in code your contract that uses loop or can be quite expensive to run or are recursive functions, kind of things like that, right? We can do something called in our test environment and test to see how much gas, right, the functions to run. So I don't know. That's kind of way I can explain it. So I don't remember how do we do that. Okay, so we did something like this. We added an attribute called available gas. I don't know. I need to turn off this. I don't need it. Sorry. So we did something like this: available gas, then L2 gas, summarize tax, and then we do something like this: amount 3 is greater than. So don't mind. Let me just use this. So in our previous class, we fixed this also. This from the contract decrease counter. So this is supposed to be less than 0, less than or equals to amount. So if I've not lost you by the way, so if you can see this from my terminal, you can see for each test, you can see L gas, L1 data gas, L2 gas, right? Layer 2 is StarkNet blockchain, right? So when we are running our tests for testing because we want to be cautious about optimizing functions, right? So in that we're trying to save more gas. All right. So to do when we are doing such, we can now define in our test, like oh, for this particular test, I want it to use 20,000 gas. Right. So in the case you run that and the test ends up using more than 20,000 gas, which in that case it will most likely use more than you can see this using 646,000 gas. Right? So in the case that your test uses more than the specified gas you made available for that test, right? The test is going to fail. I don't know if that's a good way to explain it. So when we are testing loops, we can use this available gas feature or this available gas attribute to ensure that our loops or those kind of functions are optimized properly and do not use more gas than required. You will understand. all the tests are passing now. So if you understood what okay, good. So all the tests are passing now, all the tests we are getting before. So going over to those tests, going back to those tests, you can see we wrote an increased counter test, initial counter tests, decreased counter tests. Then added this one should because from our counter constraint, we added the constraints that prevent the user from decreasing the counter um, below zero, right? So yeah, it showed the zero, slight decrease the counter below zero, and then we undo it using should panic, so it doesn't fail. The test doesn't fail. So moving forward to what we have to do today is testing events. Testing events. What testing events really, how it works is, right. If you go back to this code, you see that for whenever we increase the counter, right? Sorry. Whenever we increase the count, you can see it's emitting an event, and that event is the counter increase event, right? So whenever we increase the counter, it's that event. And whenever we decrease the counter, it also emits that event. And now we want to write a test that ensures that whenever we increase the counter, it's emitting the right event, right? And whenever we're decreasing the counter, it's emitting the right event. So we can test the output of it. We can test that an event is emitted using SMH, right? So that's what we're going to be doing now. Firstly, so back in our test, we start writing the test by using the test attributes, and then write the function test increase counter emits event, right? That's our function here. And once again, can just stop this. This is basically the same thing. So with this next thing we're going to do, we need a cheat code, right? We need a function that is provided by the SFO library, and that function is called spy event function, right? So to use that function, we have to import from the SFO library. So we'll go back here under the SFO standard library. We are going to import things. The first thing is going to be spy event, and then create event spy assertions traits. Yeah, that should be it. So we need two things: the spy event and the event spy assertion trait. We use the spy event function to assert that events are emitted as they should. Make it a mutable variable. We save it as a mutable variable and say let new spy equals to spy event. Then next thing we are going to try to increase the counter, right? And then we assert that the calling function increases emits the right event. So we're going to call the counter which holds the contract and its entry points. So counter dot increase counter function. You can specify the amount you want to increase it by, let's say 10. Right, but if you remember, use link to ensure that only the owner can call that function. So we're going to cheat the contract again. So start cheat caller address first that I want to cheat, which is the one we have specified. And we want to specify the contract I just want to check out as the owner, since we use the owner to declare the contract. All right. Then next, we now use spy variable, right? Against the spy events method, and then we use the method as emitted. That's all other assets, but this is provided by SM itself. Not it's not an asset macro, right? So it's kind of different. And what this expects, it expects a snapshot of an array. So when you see this art represents the snapshot. So create a snapshot of an array, right? And array takes in a tuple, right? A tuple of the contract address that is emitting the event and the particular event that is being emitted with the values of that event, right? So let's say we want to say um create event like this. Need to get the particular event that is emitted with the particular values, right? That the event is emitted with. So if you come back here to this contract, you see we have a event, right? Every contract has the event enum that contains the event defined in it, right? And this struct, they have a value, right, that they hold. So the event struct, our event struct is simply just meeting the counter, the current counter value, right? That's simply what it's doing. In other cases, we can as much once, right? Because when you are interfacing with the front end, there's this emitted event that we use to check things go as planned, right? So is what we need to get, and we need to pick the exact event that will be emitted. So we can do that by, since we already have our counter contracts imported here, right? And if you come here, you can see that under the counter contract module, right, we have the event enum is set to public. So if your event enum is not set to public, by default, Cairo, by default, all these are private in Cairo. So you have to set it to public for you to be able to use your tests or other places where you can import it. So and all the events you can now get the particular enum that we are looking for. So back here, we have that counter imported. You can now counter the counter mode under the module. We're looking for the event enum, and under the event enum, we're looking for particular counter create event, right? So now we've gotten the event we're looking for, but you remember we want to get the part, we want to assert particular that a particular event was a particular value, right? That's what to assert. So we're expecting is this is for value of the counter. So we just pass it as the parameter of this function, and then you pass the particular event itself. So we're passing the enum of the type of event, right? And inside that we pass the particular event struct the data is carrying. So to do that, we have to that's one thing you need to know, right? If you are not careful about your reporting, that's why you need to understand a little bit of the file structure Cairo to be able to do this properly. So now we've imported the enum, right? So now I want to import the particular struct. So that's why we're going back to Cairo to contract, a bit contract module, which is counter. And inside that counter module, you can see that public. All right, so we can similarly import this counter into this, right? And now the counter includes expect what the particular value of the. So now, remember when we're calling the function, the entry point, with the value of what 10, past 10, and according to our function, it takes an amount and emits that event, right? It emits that event. This is the struct, and it emits the current value that we pass. So whatever value we pass to the counter, that's what it's going to emit. So now from here we pass 10, so we're expecting it to emit the struct takes counter, and the value is supposed to be what 10. Do you understand what how we got here? I hope you understood how we got here. So yeah, now the assert emitted from method expect a snapshot of an array, right? Which an array of tuples, right? Which takes the contract address that I want to assert that emitted the particular event, and then the particular event you're asserting, right? Which is correct values. These are the um two arguments to expect. Then after that, we can now stop cheating and say stop cheat caller address, contract address that I want to stop cheating. So with this, we have our tests testing the increased counter event, right? And then you can run start tests once again. So that should emit the event. When this is increased, it emits the event and uses the spy function, spy.assert emitted method to assert that this particular event was emitted. Else, it will throw an error. It's still compiling. Missing terminal semicolon. The time is switching right here. So I don't think time to use. Do you have any question concerning that? Concerning testing events? So you can go ahead, if you are following, you can go ahead to start writing the test for the increase, for the decrease counter. This is so slow. Hmm. So let's just go ahead and write the next test at this point. But then needs to compile the test first. So any question? I can answer a question why the test, okay, the test is passed already. So as you can see here, you can see the test decrease counter. Yeah, I mean what I should have done is I should have just filtered the test and ran only the particular one. But then, so you can see the test increase counter emit event is passing, right? That shows that our test is emitting the right event, right, with the right value. So if there is a slight change in the value and we don't update our test is going to fail. Like this now, if I should run the test, that's going to fail. So that's to emit the correct values for the test to pass. So we can go ahead to write the test for decrease. Um, Basically does the same thing. I can read it on out. I didn't get that. Could you try again? And then we write that by ourselves. So move on to the next thing. If there was no question, if there was any question, please you can ask now while we're still on that. Else we go into talking about safe dispatcher, right? So if you remember from the previous class, we talked about dispatcher, right? That dispatcher is generated by the compiler, right? And gives you access to the entry points in the traits of the contract, right? So you can see all these are called entry points, all these functions, all these methods are called entry points. So the dispatcher basically gives you a way for contracts to interact with another contract. So now we're now talking about what a safe dispatcher is. So basically, a safe dispatcher works like a dispatcher, right? Just that in this case, if there is if there's an error in the contract we're trying to call, like this, if you see this now, when we're using this normal dispatcher, right? If there's an error in the contract, the transaction is going to fail, right? The transaction is going to fail. Imagine now, this is not just calling only one contract, right? Because in this our case now, we're using only one dispatcher, which is calling one contract. Imagine in some cases where you have several dispatchers calling several contracts, right? So one error in one contract, right, would cause this whole transaction to fail. So that's what comes in with safe dispatchers, right? Now, one thing to know is that are not only used in tests, right? You can use them in normal in writing contracts in general, right? So it's the safe dispatcher just returns a result that allows you to undo the different scenarios where either the transaction or calling the contract fails or it doesn't fail. So basically, how we describe that, we say we call it a panic. All right. So whenever we use an assert, right? Let me just say, okay, this is an assert. So what this does when comparison doesn't work, it basically just panic, right? So that's what it's called. It's called a panic. So behind the scene, this is just calling a panic function, right? So when the compiler sees that a code has panicked, it knows that an error has occurred. So using the save dispatcher, in case there is an error in the contract, we can undo that scenario. So let's just go ahead to write in that code. Now to use save dispatchers, we have to specifically add the save dispatcher feature in your code, right? And this is just how we do that. So just also add it right here to tell the compiler that it should undo the scenario where the contract fails, right? Else, once there's an error, the contract just the test just fails, right? But the same dispatcher feature, it tells the compiler that it should return a result that we can use. So let's say test hmm, increase. Let's see the function again. So we cannot increase by 0, right? So that's what we want to test. So test increase by 0 using safe dispatcher. So basically, if you have to do the same thing. So if we're trying to be more efficient with our code, we can even do it instead of having to repeat this every time. You can just add this dispatcher right here inside the deploy contract function, right? And then return the both of them, both to the contract address and the dispatcher that we can use directly. But you can do that when you're working. But for now, we'll just have to copy this. So once we have that, we have to cheat the contract again. So we can call the increase function. Oh, so yeah, I copied the normal dispatcher. So basically, the same way the compiler generates this dispatcher, it also generates a safe dispatcher. The same convention, which is just the name of the trait, right? And just add the dispatcher behind it, right? You can see the name of our trait here is I counter. So just that and add the dispatcher behind it. That's the same way it generates a safe dispatcher. So it's basically the same convention. I counter to the name of the trait, then safe dispatcher. Then also we also want the I counter safe dispatcher trait. I'm not having any typing. So now we have that imported, and now we can now use the I counter save dispatcher instead of this dispatcher. Why is that? Are we following? I'm not getting any reaction. If there's any question, please ask. I know that people are following. So now, once we have the I counter save dispatcher imported, so that's what we're going to be calling. This counter dot in this function now we're going to be calling it on the I counter save dispatcher. But one thing you need to know is that this save dispatcher, unlike the normal dispatcher that when you call it returns just the value, this save dispatcher returns a result that we can use to undo scenarios, right? So it returns, so in case an error occurs, it returns the panic data, right? It returns the error information that we can use to undo the scenario. So to do that, we have to use the match statement, right? And we can say match counter. Let me add something here so we know that it's a dispatcher. Counter save dispatcher. Right? Then we call the increase function. Right? What we're trying to do, let me explain what we're trying to do. We're trying to increase the counter by 0. And according to our contract here, right, we cannot increase by 0. So whenever we try to increase by 0, we're going to throw this error. Amount cannot be 0. But we'll handle that case in our test using save dispatcher. So we try to increase by 0, and then we use the match statement to match that if the result is okay, right? So then in that case, since we don't need the return value. So if the result is okay, we want to panic. So this panic function basically it just throws an error, like throwing an error. So we want to panic with an error, and you can see the counter increase by 0, which is weird. So we expect you to throw an error. So we're trying to handle the scenario where this could throw an error. So if the result of calling this function is okay, right, we want to throw an error ourselves, want to panic ourselves. And this is the panic data we're passing. Else, if the result is an error, right, we now want to get the panic data. Why? Because using save dispatcher, we can handle the scenario where this calling this contract throws an error. So we can handle that safely. Right. So if calling this throws an error, it's saying it's the panic data for us. So we can use the panic data, right? So pass the panic data and then undo that. So if it throws an error, we want to now assert that the error is throwing is the error that we are expecting, right? And what's the error we are expecting? We're expecting to see amounts cannot be 0. So want to expect that the panic data at 0, first we're going to snap it. So basically what this asterisk means, I know I'm going through a lot of things right now, but just follow along. So what this asterisk means is a snap operator in Cairo. It basically just extracts the value from a snapshot. So if you remember, when we use the at symbol, we are passing a snapshot, right? The snapshot is just a copy of the value without losing ownership of that value, right? So with the snap operator, we are we are getting out the value out of the snapshot. So this is basically passing the snapshot. I want to get out the value at this, right? So if you come back here, you can see our panic data here, right? So we are desnapping that, and we want to assert that the value of our panic data is equal to amount cannot be zero. So in the event that we call the increase counter with zero, right? And the result of calling that is okay, it doesn't throw an error. We want to throw an error because we expect it to fail, right? So in the event that calling that method throws an error, we want to now assert that the error is throwing the error we're expecting. So the panic data should be amount cannot be zero, right? Else, if that's not the panic data, we want to now give a panic data, right? This is basic assert that we'll be talking about. So we're just asserting a comparison that this should be this, else we say should have panic with amount not zero. That's so we had the semicolon after this. And that's how we handled that scenario using the safe dispatcher. Right. So instead of you just throwing an error, you have been able to handle that error. So in case we're having several dispatcher calls, right, we can handle each of them using the safe dispatcher easily. So after that, I want to stop the cheat scholar cheat code, and then I'll pass the contract address which you are cheating, which is this. So with our safe dispatcher, I think I'll be able to handle that scenario. So you can try running this. I try running the test and see what we get. So any questions so far from Save Dispatcher? I'm not seeing anybody asking any questions. Surprising. I'm expecting to see people asking questions. Well, I believe you guys understand my explanation very well. So our test is running. Has compiled the test. Uh, while that is running, we'll do something else. Wow. So 6 tests passed, 0 failed. So you can see try test. Test increased by 0 using safe dispatcher. Right here, our test is passing. I hope the test passing on your end also. And if you have any question once again, please ask now. Just ask now. So I can do a little thing now to test another scenario where our test to break, right? And now we are trying to increase the counter with 0, and we expect it to panic, and then we are doing the panic scenario. But if I try to increase it with 1, right? If I can increase counter with 1, it's not going to it's not going to panic, right? And because of that, the result is going to be okay. Say dispatcher is going to return a result of okay. And when you return a result of okay, we're now panicking ourselves. So what we expect to get is this panic data counter by counter increased by 0, which is weird. If I run the test again, that's definitely what we'll be getting. All right. So with that explanation, I think I'll be able to explain how we can use save dispatcher to undo scenarios, right? Where if a failure in the contract, right, can be handled without breaking anything, without breaking the test or breaking transaction. Because most times it's usually several dispatcher calls to several contracts. So that's why the safe dispatcher is needed. So apart from that, I think we're going to talk about is false testing, right? I don't know. I don't think there's anybody on this call anymore. So just leave a reaction, leave a response. Like I'm sure that there are people following me. Is there anybody hearing me? Nobody's responding. Ah, I'll just send the class. Since I'm not teaching anybody. But I believe people are here. All right. So we're going to go to first testing. I think our test has finished running. And you can see one test is failing, right? It is test increased by 0 using safe dispatcher. And all the failure data, the failure data is counter increased by 0, which is weird, right? So if the counter didn't even increase by 0, it increased by 1, because we put 0 here, right? So assuming we use the custom error message or something that would, but to make our test pass back once again, we want to change this to 0. So the next thing we're going to talk about is false testing, right? So basically, false testing is just a simple way to test your your functions, right, with random values. With random values. So how that works basically is using SNForge, you can do false testing. If you come to your scarp.com and if you had used if you have selected StarkNet Foundry when you were creating your project, you would see under tools, you see tools.snforge. Right now, basically exit first is equal to true, It basically just means that you should stop test execution once one test fails, right? Upon the first failure. So once one test fails, it stops running all the tests. So, but the next thing you can see is further runs, right? And you can see that I have a value of 1, 2, 3, 4. That's the default value. Number of runs of the random fuzzer. And then you can see further seeds, which is 1111 seed for the random fuzzer. So what basically what this means, these are what we need for first test, right? And basically what this further runs means is basically the amount of times you want the fuzzer to run, right? So that's the amount of random values that is going to run your code by, right? So it's going to run your function passing random values of 1234 times, right? And then the further seed is basically just a seed, right? That you specify. Is a value that is specified. I can specify any value, specify one, I can specify whatever I want. But with this seed, with this further seed, is we are able to reproduce the random value that is generated by the fuzzer, right? So basically, when you run first testing on the function, the compiler, right, or the test engine is basically just spinning random values. For example, for this our increase counter function, if we do when we do first testing on it, right, and we are expecting it to pass a value to increase the counter, so it will just be increasing by 10, 100, as many random values you can come up with, right? So now it's going to increase by 10, then increase by, I'm just giving a set of random values, right? Increase by 10, increase by 1000, increase by 1, and so on. But when you pass a specific further seed, right, it allows you to be able to reproduce the the randomness, right? So if without the seed, whenever you run a whenever you run the further, right, it just creates a set of random values. If you run it again, it creates another set of random values, that kind of thing. With different seeds, we create different set of random values. But with a particular seed, right, every time we run the further, it uses that set of random values. I think that's why I can kind of explain that best of my understanding. So yeah, now we're going to write our first test. And basically just the same way it works. You have the test attribute. But this time after that, you add the further attribute. You add the further attribute right after that. And next, we can now define our function and say, let's say test increase false, right? And then we have to accept a value, right? When we are using a further, our test function has to accept a value with a specified type, right? So let's say the amount we want to increase our function by, right? And the expression was V64 according to our counter contract here, expressing an amount of V64, right? So once you specify this, when the contract or when the compiler is generating random values, it's going to generate random U64 values and pass them right into this function, right? Using the fuzzer. And once again, we have to use our dispatcher and uh, copy this again. We have to deploy the contracts and use our dispatcher. And we don't necessarily have to use save dispatcher for that. You can just copy this right here. And then with dispatcher, we have counter contract here. And let's see, we have to cheat the contract, start to call address, contract address. I have to check it out owner of the contract. Then the next thing we want to do, we want to call the contract dot include counter. But this time we're passing the amount that our fuzzer gives us, right? So we're passing the amount that our fuzzer gives us instead of passing our own value. So the fuzzer is just basically going to give us a value. But for the test, what we really just want to do, we want to assert that. We want an assertion, right? Because according to the anatomy of the test, there should almost always be an assertion in your test, right? So first of all, we get the initial count, which is almost always there because of our when we're deploying the contract, we said 0, right? Then so I don't think we need that. So I don't think we need the initial count. We can basically just assert here and say that the counter we get the current counter value and assert that is equals to the amount that the folder gives us. So if we increase the counter by the amount that the folder gives us, we want to assert that the counter is equals to the amount that the folder gives us, else we can pass a custom error message, right? Like we explained before, expected, you're expecting to see the further amount, right? So we can just put this is the amount passed by the further expected the but counter is this, right? So in this um places, these placeholders that are left here, these variables to fill these placeholders for the customer error message. So this amount to be passed here, expected the amount, which is the amount passed by the fuzzer, but counter is so counter dot get counter. Right. I think that should work. Then we always have to stop spoiler address. Are we following? Just run our tab test again. This time we should run with the fuzzer. Why? Because we specified the fuzzer attribute, right? So this is a simple example of the first testing. And according to the default staff.tom, this fuzzer is going to run 1,000 times, right? And I don't see any reason why we should allow this to run 1,000 with 1,000 random values. So we can just do this and override that default value, and let's say runs 100 times. You can also override the seat and override the seat, and let's say seat one, or 1 to 2. Just start on the test again. If there's any question, please do well to ask. But if you remember that from our increase counter function, there's a constraint, right, which doesn't allow us to increase the counter by zero, right? So we cannot increase the counter by zero. And what if our fuzzer tries to seed this with zero, right? Try to pass zero as an amount. It's going to break. So let's just hope our fuzzer doesn't do that. But then we can add a condition that allows that to pass, right? And add the condition for that. So right now, I'm going to ask you any question that you might have concerning what we've done throughout in the three sessions so far. Have any question relating to Cairo? I'm all ears. So you can see our tests are passing, test increase, counter emit event. So that's our event tests. Our safe dispatcher test passing also. Then you can see this tests increase false. These are false tests now. It runs 100 times, right? And see the amount of gas it is. So our test run 100 times, and you can see the seed value. So that's just basically how false testing works, right? So um the tests SN forward basically just passes random values to your function. You can increase this to as many as much as we want. So we just use 100 there. We can change the seed anytime. So what I wanted to add was a simple condition that allows the test to pass. Just in case that further passes zero, right? So it doesn't break. Since our contract doesn't allow us to. So let's just say if amount zero, just want to return, right? So we just basically skip that first test. So it doesn't get here because if it gets here, it gets to pan right? Because our contract doesn't allow us to set as zero. So that's basically it. And then we can run the test again and add semicolon here. So now I'm fully answering any question you might have had over the course of the class. Please ask your question now. Nobody's asking any question. There's any question in the chat. So there's no question so far. No question. So once again, I'll test for person. Yes. Fuzzer is running 500 times now. So basically, that's it about testing, right? Covered quite a lot into testing. If you have any questions, you ask now. I'm not getting any question and I'm bothered. Because I thought I would have confused a lot of people. So since there's no question, I'll just ask my question before in class. Right. So the first question I want to ask is what's the difference between a dispatcher and a safe dispatcher? Anybody? What's the difference between a dispatcher and a safe dispatcher? Nobody's answering. Let me see what you can class. Jobusku, Daniel, Dasola, Choma, Adex. Nobody's answering my question. Wow, everybody has gone to sleep. That's the case. We're ending the class. So the last thing would be the assignment. Right. And I'll share this code in the chat. So somebody please remind me to do that. Then for the assignment, I'll send the link to the assignment form. I'll send the link to the assignment form in the group chat as well. But for the last time, is there any question? I don't know, maybe it's my mic that is not working. But then I'm asking once again. Okay, if that's the case, we're ending the class now. And thank you all for joining. Thank you for your time. You've learned so much about testing, and you get better if you just go ahead and spend your time watching the videos, trying to replicate the code on your end. And if you encounter any error, share it on the group chat, figure it out together. So yeah, thank you everyone. Good night.